Not every time will we be given all the information that's required for a question. We'll also be given questions that have no equation given, and therefore we need to actually use some description clues to develop the equation. One good way is to help us set up a chart with our known values, or using let statements and determining what we actually have. Overall, what will happen is that many times you need to consider previous knowledge and apply it where necessary. So our first example is Stella takes 4 hours to paint a room. It takes Jose 3 hours to paint the same area. How long will the paint job take if they work together? So what we can say is that within 1 hour, Stella would be able to paint a quarter of a room. So we have her time, her contribution as x over 4. We can add to Jose's contribution, which would be x over 3. The two of them together would be able to paint one full room. And from there, it will actually go quite quick. So that's Stella, that's Jose. Get our common denominator. So this one would have to be multiplied by 3 over 3. This one by 4 over 4. And this one a 12 over 12. We would get a 3x, add 4x over 12, equaling 12 over 12. So this one's really nice and easy to work with. We have 7x over 12, equaling that 12 over 12. Well, first bit of work that we do, multiply both sides by the 12. Seven x over 12, and divide by that 7. So what this is saying is it would take 12/7 of an hour or 1 and 5/7 of an hour if they work together. Second example, Marissa can paint a garage door in 3 hours. When Marissa and Roger work together, they paint the same door in 1 hour. How long would it take Roger to paint the garage door on his own? So we look back to what we have just done. It's almost the same kind of setup. There's just one key aspect. We don't know how fast Roger can work. So first thing is we know that Marissa can paint in 3 hours. So in 1 hour, she will have painted 1/3 of the entire room, or room, door, yeah, everything together, 1 hour. What we don't know is how much Roger would actually be painting. And that's actually what this is. This X here is saying we don't know how long it would take. So by completing the rest of this, we can help solve. Now, don't be discouraged if this part doesn't really make the most sense. Our examples further on will help a lot more. But we still need to get our common denominator. And this one we have to be multiplied by 3x over 3x. X add 3 over 3x equals a 3x over 3x. Get one side equals 0. So we're going to subtract the x and subtract the 3. I know I can't factor anything out of there, so I'm good to continue and finish off the rest of my work. Quickly solving this. X is 1.5. So it would take Roger 1.5 hours to paint the same door, just on his own. Okay. Where it gets more fun and more actually useful is actually, well, I say useful because I like physics. I know, I'm weird. But all of this actually works out a lot better when you start considering, when you do start considering physics. Or if we start talking about Science 10, where we have things that, or an equation that speed or velocity is distance divided by time. So example 3 is a train has a scheduled run of 160 kilometers between two cities in Saskatchewan. If the average speed is decreased by 16 kilometers per hour, the run will take a half hour longer. What is the average speed of the train? So what we need to do is we need to find a speed. But we are given a whole bunch of different things. We're given a distance, and we're given a speed, and we do have one time. What we need to do is find out how fast these speeds are, which means our speed is going to be our x. That's going to be our variable. That's one thing that we're going to solve for. I know for this example, what we need to do is we actually need to solve for time, which means we multiply both sides by t. So a t multiplied by v would equal d, and divide by that v. Distance divided by speed equals time. So for this example, it says a train is scheduled to go 160 kilometers. But when you decrease the speed by 16 kilometers per hour, it takes a half hour longer. So our distance is 160 kilometers. If we divide it by the speed, which we'll call it x, it would equal the same information. But if we decrease our speed by 16, it takes a half hour longer, which means we have to add 1/2 of an hour. What we have now just done, to help make this a little more sense, distance divided by speed, this part is talking about time. This right here, distance divided by speed, is still time. This is also time. That half hour longer is a time variable. Now, I'm not actually going to use those t's, but we are going to solve this. Get our common denominators. So let's see. This one is going to have to be multiplied by a 2 and an x subtract 16. To make our lives easier, I'm going to make it a 2x minus 32. This one is going to be multiplied by a 2 and an x. And this one would have to be multiplied by the x and the x subtract 16, which means x squared subtracting 16x. Just makes your lives easier. Now we distribute. Let's see, we have 320x, subtract the 160 by 32, 5120, and be all over a 2, an x, and an x subtract 16. And 20x, adding, say, a 1 multiplied by x squared subtract 16 would just be an x squared subtract 6, or x squared subtract 16x. My denominators are all good. And then we do some manipulation. So we subtract the 320x and add the 5120. So we have 0 equals an x squared subtracting the 16x, adding a 5120 all over a 2x, x subtract 16. And we're going to have to do some factoring. So a product of 5,120 and a sum of negative 16. That's a toughie. That should be 80 and 64. X subtract 80. X add 64. Let's make sure. Just going to quickly check on my calculator. Yep. Yes, you should already know I'm magic. I can do big numbers in my head. Get rid of my denominator. So x subtract 80 and x add 64. Two solutions, 80 and negative 64. Well, obviously, only one of them makes sense because our x was talking about speed. Negative 64 as a speed can't work out. Average speed, 80 kilometers per hour. Right. Last one, we're going to apply the exact same kind of information. Mario drove from Edmonton to Grand Prairie and back, a distance of about 360 kilometers each way. Mario's average speed was 30 kilometers greater on his return trip than his trip out. His total driving time was 10 hours. Determine Mario's average speed on each leg of his journey. So it uses the same kind of principle as what we had done up here. But time is distance divided by speed. Well, our total time here is 10 hours. We're going to have to have a distance divided by speed. So we have two distances. They're both 360. 360 divided by speed. That's what happened. That's his speed when he's going there. But when we're going back, his average speed was 30 kilometers per hour greater, which means x add 30. And then we can solve. This one is going to need an x squared add 30x. This one's going to need an x add 30. And this one's going to need an x. So we have a 10x squared adding 300x over an x and an x add 30. So 360x. Let's see, what's that one? $10,800. Plus another 360x over x and x add 30. So we want to move everything over. So we want to, if you're fine with this, 360 and 360, 720. So subtract 720x and subtract the 10,800. Oh, need to make sure I subtract that 10,800. We get a 10x squared should be a negative 420x, subtracting 10,800 all over an x and an x add 30. That should equal 0. It's going to be really difficult to try and factor a product of negative 108,000 and a sum of negative 420, so we can factor a 10 out. Might not be, or you may not think that it's quite as nice, especially dealing with 1080 and 42, but it really is. So, you know, it's going to factor as a nice simple trinomial. And what would our nice numbers be? So our nice numbers would be a negative 60 and a positive 18. X at 30. So all in one fell swoop. We can have our solutions. All that cancels off. 10 never equals 0. X would be 60 or negative 18. But X is talking about a speed. So that one doesn't make sense. Meaning 60 kilometers per hour there. And 60 plus 30, so 90 kilometers per hour back. And there we have it.